Outliers pull the mean. 1 point can mislead. Watch the extremes.
Welcome to the estuary census. When we count two different animal groups out here, we compare them by looking at how their data is shaped, where it centers, and how widely it spreads. Take these two counts, a spring flock and an autumn flock. Setting them side by side reveals the patterns in each population. Watch for the outlier. One unusually large record can stretch the range and tug the mean, shifting the data. By identifying these outliers and describing the spread, we can explain what is actually happening with the animals we're tracking. Let's look at travel times for two groups of students. Class A and Class B both have a median travel time of 18 minutes. These plots show the difference. Class A's times are tightly clustered between 15 and 21 minutes. Class B's times are scattered all the way from 5 up to 40 minutes. Even though their centers match, the physical spread of the data reveals that the groups are not identical. Because Class B's range stretches so much further, the daily travel time for those students varies much more. This means Class B has much more variability in travel time, even though the typical center is the same as Class A. In this set of test scores, almost every shell sits in the 80s range, except for one single score down at 20. Consider how that one isolated score changes the way we summarize the performance of the whole group. That score of 20 is an outlier. It pulls the mean downward, moving the average away from the main cluster where most students scored. It also increases the total spread, making the group scores look more varied than they actually are. We must note the outlier because it affects the calculation of both the center and the spread. Finally, we can compare the wait times at two different stores by looking at the shape of their data. At Store A, most customers wait around 3 minutes, but a few experience much longer waits, creating a tail that trails off to the right. Because of that cluster on the left and the long tail on the right, we call this shape right-skewed. Store B is different. Its wait times form a symmetric mound centered at 5 minutes. This shape tells us that the typical wait time is also the most common wait time. When we compare these, we describe their shapes. Store A is right-skewed, while Store B is roughly symmetric. When you use shape, center, and spread together, you can make clear claims about the data you find. You can now combine these observations to explain why one group has a higher center, or why another is more spread out. Interpreting these shapes, centers, and spreads allows us to build comparisons using evidence. Before you head back out, consider this. How exactly do outliers affect the center?
Outliers change the story. The median resists them. Read data carefully.